Welcome to 2020, question A4. This is a Skew Lines question. So the image below shows a fragrance bottle and diffuser. So we've got our diffuser here and all our skew lines coming up out of the bottle. The given elevation and plan show two similar reads represented by the skew lines AB and CD. So AB and CD are our skew lines. Determine the projections of the shortest horizontal line between the skew lines. So what we need to do is set up a plane. This has come up plenty of times before in the past. So I'm going to set up a plane by creating a level line there from B, and I'm going to go parallel to CD from A. So parallel to CD from A. Okay, and that has created this plane here. Alright, and my line here is a level line, L, L. Alright, so what I want to do is I am going to locate that plane in plan also. So we call this point O. So we've got plane A, B, O. So O, I'm going to project that down, okay, but I don't know where it is. But I do know that this line AO is parallel to CD. So I'm going to go parallel to CD, parallel to CD from A again. Okay, so those are parallel lines. And that will locate me my point O. So I can join that back to B. So that line is actually a true length line because it's a level line, so a horizontal line here in elevation. So when I look down on top of it in plan, right, it's parallel. So up here, horizontal line. Okay, and when I look down on top of it, we're perpendicular to it, so it's a true length line. So what I'm going to do is I'm going to look out along that line so that I can get a edge view of this plane. Start my set squares. I just think I will set this up. There we go. So slide my set square out. So here is my x1, y1. So all points now I'm going to project through to 90 degrees. And what I'm doing is I'm creating an auxiliary elevation. Okay, I know it's an auxiliary elevation because I'm projecting from plan. Projecting elevation, plane projects to an elevation. So my heights then are going to be taken from the elevation. So I'm going to get the height of C. C is on the XY line. Is on the ground line or horizontal plane, so that's C. Okay, A, I'll get that distance, A. I'll step it up. So that's my position of the A, and B and D are both at the same height. So B is here and D here. So B, D. Now what we should have is a set of parallel lines. Okay, so both of those lines are parallel. Now, we're looking for the shortest horizontal distance. If I was looking for the shortest distance, I would look perpendicular to these lines. I'm just looking for the shortest horizontal distance. So, think of elevation here, because this is an auxiliary elevation. In my elevation, my XY line is a horizontal line. So here's another elevation, an auxiliary elevation. So my XY line is going to be my horizontal line. So I'm going to look out perpendicular to that line. So sliding sets first. Okay, just moving that. So that's my x2, y2. Okay, so project out all of my points. Okay, so I've projected from a plane to an elevation and it's coming back to a plane. So this is an auxiliary plane. Okay, so I need to go back 2 views to my plane, and the distance from my x1, y1 to my plane view will be the distance as I step up here. So we'll start with C, step up here for C, then don't forget B, so B, A, and D. So there it goes up, C, this is B, D, and A. So C joins to D, B joins to A. Where does lines cross? Okay, that is the point view of the shortest horizontal distance between those 2 skew lines. So what we're going to do is we're going to project back and find those lines, because we're looking for the projections of that shortest line. So we're going to project back and find the location of that line down here. So here we have it. That is the horizontal line, shortest horizontal line. Okay, and I'm going to project that back into my end elevation, or into my plan view. So on line CD, project this onto line CD. On line AB, project onto line AB. So here's that line again. Okay, and finally we project that up into the elevation. So on to line AB and on to line BC. What we should have there is a horizontal line between those two. So see there, horizontal line found above. Okay? And that's proof that we did find a horizontal line, if it appears horizontal in my elevation and also horizontal, remember my XY line, X1, Y line is horizontal in my auxiliary, so it's horizontal there as well. Then finally, determine the true length of the line, a line joining A to C. Right, so I'm going to get a line here joining A to C. There it is. I'll actually highlight it. And a line joining A to C. Okay, so we have 2 methods of doing this, well, a number of methods, but the ones I'll be leaning towards is 1, take an auxiliary view, so looking perpendicular to this line, x1, y1 here, and it's projected from the plan, so I would take my heights from my elevation, okay, because it's an auxiliary elevation we're creating, or we can rotate this line around. Okay, I'll do both very, very quickly. Step off at my x1, y1. I should step off a little bit of a distance just so we can see. Okay, and hard to get this set up correctly. The set squares are kind of out of line. So x1, y1. Okay, I'm projecting from a plan, creating an auxiliary elevation, so I can take my heights from my elevation. A is this height, so I can step A up here, and C is on the xy line, so C stays on the xy line. So that is method 1. That's A, C, and label that as a true length. Okay, so that's method 1. Method 2, like I said, we can rotate this around. So I'm going to rotate around until we have a line that we're looking at perpendicularly in elevation. So rotate AC around. Okay, so that's the position of it there, and I can project that up into my elevation. Okay, so A is the point which I was rotating about, C was the point that has rotated, so C comes across, and that is also true length. So that's method 2. Okay, whichever way works for you, or whichever one you prefer to do. Okay, both are fairly quick methods, so there's not much of a difference in terms of time and completion. Okay, so that's 2020 question A4, the Skew Lines question.